AI can write Python code in seconds, and I don't mean just hello world. Give it a real task, clean a dataset, handle missing values, analyze it, generate visualizations, even start building an interactive dashboard, and it can produce a surprisingly good first version almost immediately. It can explain the code, debug it, rewrite it, write tests for it. So if you're learning Python right now, there is a pretty reasonable question to ask. Why bother learning it at all? Why spend your time learning variables, loops, functions, and data structures when AI can already write the code for you? And I think that's actually the wrong question. The better question is, what does learning to code mean when AI can code with you? Because yes, I still think you should learn Python, but I don't think you should learn it the same way we did before generative AI. First, we need to acknowledge something. AI really has changed programming. Traditionally, you had a problem, you needed to understand it, then you design a solution, write the code, test it, and also figure out what went wrong. Now, AI can enter that process. So you describe what you need, you frame the problem, AI can help generate the implementation, and suddenly, the part that used to take a lot of our time, physically producing code, can become much faster. But look carefully at what didn't disappear. Someone still has to understand the problem, the framing the problem at the beginning. And also someone still has to verify it, has to decide whether the result is actually correct at the end. AI moved into the workflow. It didn't make those two responsibilities disappear. Neither did refine and ship. Let me show you why that distinction matters. Look at this line. Average this sum values over length of that values. Is this code correct? Maybe. If values contains ordinary numbers, yes, it works. But what happens if values is empty? So if it's empty, we are going to be dividing by 0. And Python will give us zero division error. Then the program will crash. But strangely enough, that's actually the nice kind of failure because at least we know something went wrong. Now imagine the program didn't crash. Suppose our values can be anything. Maybe let's take 12, 15, or in this case 21.4, 22.1 minus 999. And what would it give it? Some datasets, as you know, use special sentinel values, such as minus 999, to represent missing or invalid data. But Python doesn't automatically know what minus 999 means in your dataset. To Python, that's just another number. So our code ran. No error, no warning. We got an average here. It just happens to be completely meaningless for the problem we are trying to solve. And this is the distinction I want you to remember. Code can run perfectly and still be wrong. Generating syntactically valid code and understanding whether that code is correct for your problem are not the same skill. AI doesn't remove that distinction. If anything, as code becomes easier to generate, being able to evaluate it becomes much more important. Now, I don't want to swing too far in the other direction. AI is incredibly useful for programming. I use AI tools, and I think learning how to work with them is becoming part of learning how to build software. AI can generate boilerplate, it can explain unfamiliar code, it can suggest implementations, it can refactor, it can help you debug, it can write tests, and it can dramatically accelerate prototyping. That's fantastic. But the easier those things become, the more important another set of questions becomes. What should we actually build? What problem are we solving? What does our data mean? What counts as a correct result? What assumptions are being made? And what happens when something goes wrong? AI can help us answer those questions, but we still need enough understanding to know that those questions need to be asked. So if AI can generate code, why am I still recommending that you learn Python? Because learning Python isn't just about learning Python syntax. you're gaining access to an enormous ecosystem. If you want to work with data, you'll encounter tools such as Pandas and NumPy. If you're interested in machine learning, there's Scikit-learn, PyTorch, and a huge ecosystem around them itself. If you want to turn something you've built into a simple interactive application, you can use something like Streamlit. If you want to build APIs, there's FastAPI, and Python is extremely useful for automation, scripts, APIs, and workflows that remove repetitive work. So I don't really think of Python as a collection of keywords you're supposed to memorize. You are learning a way to take a problem and turn it into something executable. And here's where that becomes tangible. Imagine I just write a few lines of Python with Streamlit. I can just create a title, then I add maybe an option to upload CSV, then drop downs. So, and I tell the application that whenever I want to visualize it this way. Okay, so then I run it, and now those few lines of Python have become an interface I can actually interact with. AI could absolutely write those lines for me, but if I understand what they do, I can change them. I can connect them to data, I can add another feature, I can debug them, I can ask AI to extend the application and then evaluate what it gives me. And when something goes wrong, I'm not completely dependent on another prompt to rescue me. That's the difference. And this is where I think the way we learn programming needs to change. If you're learning Python today, I would not tell you to spend months memorizing the syntax before you're allowed to build anything. I wouldn't tell you that looking something up means you've failed. And I definitely wouldn't tell you that using AI is somehow cheating. But there's another extreme just as problematic. Build me an app, for example. Let's say I'm just going to prompt it. I'm just going to copy. I'm just going to paste, run, error, and then copy the error. So let's look at how it might look like, right? And then we paste it back into the AI. So we will copy the new answer and we run again. So when we keep repeating it until something eventually works, you may end up with an working application. But here's the uncomfortable question. Did you actually even learn how it works? So you don't want to become someone who refuses to use AI, for example. And you also shouldn't be someone who is just going to be using it so much that the thinking itself has vanished. So both of these will not work because one is basically falling behind if you do not use it, and if you use it so much, you are never really learning. There is a way to use it. So let's look at the loop that's going to change. So first, let's try to understand. Let's start with understanding the problem. If you're learning functions, understand, for example, why functions exist. If you're learning loops, understand what problem repetition solves. If you're learning a data structure, understand why you might choose one over the other. And then you start trying it yourself. Not because you need to prove you're better than AI. You're not competing with AI. You're building a mental model. Then let's go ahead and build something, even something very small. Because the moment you build something real, you'll encounter questions that a tutorial didn't even prepare you for. And also there's something called as learning by doing. So the more you do, the better you understand the system. Then bring in AI. Ask it for help. Ask it to explain something. Ask it for another implementation. Maybe also ask it how your solution could be improved. But then comes a step I think is becoming incredibly important. Verify. Read what it produced. Run it. Then change the inputs. Test an edge case. Then break it deliberately. Ask yourself what assumptions it's making. Then use what you've learned the whole time to improve it. So the loop becomes actually understand, then try, then build, use AI, verify, and then improve. And then you go around again. Every pass you understand a little more, which means you can build a little more. And importantly, you become better at judging what AI gives you. So here's a question. Imagine you could become excellent at only one of these two things over the next few years. Option A, remembering Python syntax versus recognizing when AI-generated code is wrong. So the option B is the one that I choose because it's about verifying it. And that does not mean syntax is useless. You need to understand syntax to read the code itself. You need to know what functions, loops, conditions, and data structures are doing. But simply remembering syntax becomes less differentiating when both you and I can retrieve it almost instantly. Understanding what the code means is different. Knowing whether it solves the right problem is different. Being able to debug it is different. So if I were learning Python today, I would absolutely still learn the fundamentals. The variables, the conditions, loops, functions, data structures, how information moves through a program, but I wouldn't stay there forever. I'd move fairly quickly into reading code. The debugging, breaking larger problems into smaller ones. The problem-solving aspect of it, working with the data, using libraries, testing, and most importantly, this is the part, like if I build more projects, I secure my foundation. Then on top of that foundation, I would deliberately learn how to work with AI, how to give it useful context, how to ask for alternatives, how to ask it to explain something I do not understand, how to test what it produces, how to recognize assumptions, and when not to trust the first answer. Think of these as kind of layers. Your programming fundamentals are the foundation. Your ability to solve problems and build things sits on top of that, and AI-assisted development sits on top of both. AI literacy should amplify your programming understanding. It should not replace it. And this is why I think the skill mix is changing. So first, like syntax code, producing boilerplate, simply typing code quickly, those things aren't becoming useless. They're becoming less differentiating when AI can assist with them. Meanwhile, look at the other side. Problem decomposition, debugging, verification, system thinking, understanding data, knowing how to work effectively with AI. Those skills become increasingly important. Can you take like a vague problem and turn it into something solvable? Can you look at a result and recognize that something isn't right? Can you test an AI-generated solution? Can you understand how different parts of a system interact? Can you look at perfectly reasonable looking code and ask, what am I missing? Because if code becomes cheaper and faster to produce, simply producing more code isn't necessarily the core skill anymore. Judgment is. So here's the whole argument. Code is becoming easier to produce, which means knowing what should be built matters more. Knowing whether it's correct matters even more. Understanding how everything fits together matters more. The value isn't disappearing from programming, it's shifting. And I think that's an important distinction, because the conclusion isn't AI can code, therefore don't learn programming. It's AI can code, therefore learn the parts of programming that let you use that capability intelligently. So going back to the question we started with, AI can write Python. Should you still learn it? Yes, 100% yes, absolutely, but learn it differently. Don't spend all your energy trying to memorize everything an AI can retrieve in seconds. Learn enough syntax to comfortably read and work with code, understand the fundamentals, learn how to break the problem down, build things, debug things, work with real data, and learn how to use AI without handing your understanding over to it. Because the goal isn't to compete with AI. That's the wrong thing, because you're not competing with AI at typing Python. The goal is to become someone who can think, build, and verify with AI. AI can help you generate, it can help you experiment, it can explain, it can critique, it can give you another approach when yours isn't working. That's an extraordinary advantage for someone learning today. But the more capable the tool becomes, the more valuable it is to understand what you are asking it to do. And that's exactly what I want to explore on this channel, not just Python syntax. We'll build things with Python. We'll break down AI into machine learning concepts, and machine learning concepts. We'll explore also the tools that people are actually using now, and we'll look at what happens to software engineering when AI starts becoming a part of the development process. So the goal is simple: understand it, build with it, and know enough to question it. If that's what you're trying to learn to, you're in the right place. I'll see you in the next one.